Hello. In this first module, we will explore the relationship between golf and complex systems theory. One of the first concepts to learn when working with high performance golf players is that in golf, 1 plus 1 does not equal 2. In fact, it is crucial to effectively communicate this concept to the players. Understanding complex systems theory in relation to our development as individuals and as golf players is essential for establishing an efficient and effective process. This helps avoid practices that, while they may lead to quicker short term progress, often do so at the expense of the necessary learning required for improved long term performance. To do this, let's start by understanding what is meant by a system. A system is defined as a set of interconnected elements working together with a specific function or purpose. Therefore, in a system, the whole is different from the sum of its parts due to the synergy created by the interconnections between these elements. This definition leads us to identify three distinct components in a system: the elements that comprise it, the network of interconnections between these elements, and the function or purpose of the system. We can apply these three components to different contexts. For example, when observing the European Ryder Cup team, we identify the elements as the players, coaches, caddies, physical trainers, and so on. The interconnections between them include the rules of the game, the physical laws governing the sport, the communication among team members, and their personal relationships. On the other hand, the purpose is clear: to win the most important trophy in our sport. Let us now pause for a moment to discuss the three types of systems we can encounter: closed systems, open systems, and dynamic open systems. A closed system is a physical system in which there is no exchange of matter with the environment, although there may be an exchange of energy in the form of heat, work, or radiation. In other words, the mass of the system remains constant, but energy can enter or leave. These systems are often used in thermodynamic and engineering studies to simplify the analysis of processes. A common example of a closed system is a cylinder with a piston, where the gas inside the cylinder cannot escape, but heat or work can be applied to it from the outside. On the other hand, an open system is a physical system that exchanges both matter and energy with its surroundings. These systems allow the inflow and outflow of substances and energy, meaning their mass and energy can change over time. Open systems are common in nature and in various industrial applications. A typical example of an open system is a pot on a stove, where water, matter, can evaporate and escape into the environment, and heat, energy, is continuously transferred from the stove to the water. Finally, and relevant to our focus, a dynamic open system is a type of open system in which the system's variables change over time due to continuous interactions with the environment. Take note of this key phrase: they change over time due to continuous interactions with the environment. These interactions involve the transfer of matter and energy, and the system's conditions are constantly changing in response to these exchanges. An example of a dynamic open system is us, humans, and more specifically, those of us who play golf. When we talk about dynamic complex systems like humans, unlike closed complex systems, they often have the ability to adapt, pursue specific outcomes, self-preserve, and evolve, always in contact with and influenced by the environment in which they interact. As a result, it is impossible to fully understand the type of play and characteristics of a specific player without knowing and understanding the environment in which they developed. This is a key insight into identifying which aspects of their game still need development and the conditions required to achieve that development. Additionally, and without being redundant, these systems are self-organizing, an important concept we will explore later. On another note, the elements of a system can be either tangible or intangible. The components of a system, such as those of the human body, are often easily identifiable when they are physical or tangible. For example, the arms, legs, torso, muscles, and skeletal structure. Therefore, it is a primarily visual task to distinguish the physical elements of one player compared to another and compare them to establish standards for size, weight, height, strength, and mobility. Ideally, this responsibility falls largely on physical trainers, whose role is essential for proper physical development and conditioning. That said, we must not forget that the golf instructor also influences this physical development, as they can establish a type or volume of training that can either support or hinder that development, and even rehabilitate or harm parts of the body. For this reason, knowledge in this area should preferably be shared and coordinated among the different professionals involved. However, something more complex and equally important, though still visual and tangible, is to establish the interconnection between the various physical components of the body and define strategies that allow them to work together in a specific sequence of movements. This could be to achieve the purpose of generating power or creating a specific ball flight. Thus, it is highly valuable to measure how the player uses these elements in biomechanical and technical terms, such as the sequence of movements, the generation and transfer of energy, and the results of this use, including club speed, attack angle, and swing path. All of these aspects can be measured to the extent of extracting concrete data and images, thanks to technological advances. This task is more technical when it comes to the specific sport of golf, meaning that the golf instructor should lead development in this area, ideally supported by the physical trainer, particularly when identifying limitations that can be overcome through exercises to improve mobility or strength. As you can see, the interconnections between the elements, in this case the communication among members of a training team, are essential for better pursuing the player's goals. It is crucial that the purpose of the player, the physical trainer, and the technical coach be aligned or, at the very least, complementary to one another. This is an issue we will analyze further when we discuss the hierarchy of purposes. Given the above, identifying the intangible elements of the system, evaluating them, and establishing standards to compare different players and support their learning process is a much less visual task and, undoubtedly, far more complex. It is also, as we will see, one with a significant impact on performance. These intangible elements might include emotions, knowledge, and, among others, the executive functions and cognitive abilities previously mentioned, which are the focus of this study. This responsibility falls to a professional specialized in evaluating and stimulating cognitive abilities and executive functions, typically a neuropsychologist, who must also coordinate with the golf instructor. This is because, as we will see later, it is essential to transfer learning from the laboratory context to its application in the specific sport context. This task can only be carried out by individuals with knowledge in the field of neuropsychology and the sport of golf. Here, in-depth knowledge of the specific sport takes on greater importance. Currently, this is a very rare skill set, creating a genuine competitive advantage for those like you who have chosen to attend this course. As illustrated earlier, the interconnections in the human body include the physical flows and chemical reactions that regulate metabolic processes, as well as the signals that allow one part of the system to respond to what is happening in another. Therefore, communication between the parts of the system is essential for its proper coordination. This is why controlling attentional processes, and by extension, the importance of pre-shot routines, is fundamental to achieving the desired objectives. In other words, if at the moment of striking the ball we fail to focus our attention exclusively on that action, conflicting commands may arise within the system, potentially causing degrees of uncoordination that could lead to its collapse. In simpler terms, this increases the likelihood of missing the shot. In this regard, when discussing high-level competition, it can be said that it is extremely difficult to learn how to manage attentional processes during high-level competition without regularly participating in it. This is because the demands, emotional load, and expectations are not only higher, but fundamentally different from those of club tournaments or non-high performance events. Hence the saying, the best training is competition. Let us now address the third essential component of any system, its purpose. When referring to purpose, it is crucial to tackle a deeply relevant issue that can hinder many players, particularly at high performance levels. In this context, it is important to remember that the primary purpose of any system is to ensure its own perpetuation or survival. This is not a random statement. It is a fact we must clearly understand when designing a training plan for any player. The purpose of the brain, specifically, is to ensure its own perpetuation or survival. This fundamental principle must guide how we approach both the development and expectations placed on a player. Our brain, the governor of the system we use to play golf, is also responsible for determining whether the actions we undertake are detrimental to our survival. For instance, actions such as excessive physical exertion without enjoyment or mental fatigue caused by monotonous and unstimulating tasks. If our brain detects such conflicts, the system tasked with ensuring our survival may intervene, potentially manifesting in psychosomatic reactions, physical symptoms directly linked to psychological causes. This means that our body may suffer due to psychological influence, which can exacerbate physical symptoms. Physical symptoms may surface to mask emotional distress, resulting in issues such as back pain, knee pain, wrist pain, and other physical discomforts. This can also lead to depressive states as a mechanism to avoid those activities. Therefore, maintaining sub-purposes such as playing golf well in harmony with higher-order purposes, like socializing, is essential for the proper functioning of the system and the achievement of objectives. Considering what has been discussed so far, I would like to delve into two fundamental concepts that will be crucial for understanding the importance of properly assessing and stimulating the minds of athletes from an early age. This approach will enable us to accelerate their learning process and prepare them to adapt to the diverse demands of golf. Let's talk now about self-organization. Self-organization is the inherent ability of any dynamic open system, in this case, the golf player, to develop its own structure in an increasingly complex manner over time. This property of self-organization is so common, especially in living systems, that it is often taken for granted and not given the attention it truly deserves. In fact, all too often, self-organization is suppressed in favor of a standardized technique or method as though there were only one way to do things, in this case, hitting a golf ball. We must acknowledge that while there are similar movement patterns and physical laws that must be followed, each and every golf swing is usually unique to the player. For this simple reason, it would be far more beneficial to encourage self-organization rather than undermine it. Considering this, a more sustainable approach would be to ensure the player understands the immutable aspects, in this case, the laws of ball flight, and to create a training context conducive to the desired learning. Like resilience, a concept we will discuss later, self-organization is often sacrificed in the name of short-term productivity and stability. Productivity and stability are frequently used as justifications for turning creative individuals into mere cogs in production processes. Self-organization brings with it heterogeneity and unpredictability. It can lead to entirely new structures and innovative ways of doing things. It requires freedom, experimentation, and a certain degree of chaos. These conditions that foster self-organization can often feel intimidating for individuals, but we must face the future with courage, because if we don't, someone else will do it for us. Imagine the coach who, obsessed with teaching their idea of the perfect swing and the utopian straight ball flight, stifles a child's motor creativity and their ability to learn a broader range of movements and motor solutions for years. Or consider the coach who dictates to team players exactly how to approach a specific 18-hole course, as if such a thing were truly possible. This approach, furthermore, fails to encourage debate among team members, which also stifles creativity and the exchange of ideas, fundamental components for developing reasoning skills, and the ability to adapt to changing situations. Having explored the concept of self-organization, let us now turn to the concept that ensures a system's robustness: resilience. Resilience is defined as the ability of an organism to adapt to a disruptive agent or adverse situation. It also refers to the capacity of a system, such as a living being, to restore its initial state once the disturbance it was exposed to has ceased. This resilient capacity arises from a complex structure of feedback loops that can operate in various ways to restore a system even after a significant disturbance. These feedback loops can be divided into two types. The first one is stabilization loop. This is a feedback mechanism within a system designed to maintain its balance and stability. It works by detecting deviations from the desired or reference state and applying corrections to reduce these deviations, bringing the system back to its optimal state. This type of loop is crucial for preventing excessive fluctuations and ensuring the system operates consistently and reliably. A common example of a stabilization loop related to the golf swing is performing drills or exercises that have previously helped the player develop their swing whenever they feel they are losing it. On the other hand, a reinforcement loop is a feedback mechanism within a system where an initial action or change triggers effects that amplify that change, leading to exponential growth or decline in the system. This type of loop is characterized by its ability to intensify the outcomes of internal processes, creating a cycle where each interaction reinforces the previous one. A positive reinforcement loop in golf could be the integration of cognitive improvement games, a healthy diet, and physical exercise, progressively strengthening various aspects of the game. Conversely, a negative reinforcement loop would involve behaviors like the consumption of alcohol, tobacco, or other drugs, which would progressively degrade the system as a whole and consequently the player's performance. Given the above, it is important to highlight that resilience does not imply static stability or constancy over time. Resilient systems can be highly dynamic, experiencing short-term oscillations, periodic surges, or cycles of succession, climax, and collapse as part of their normal condition, with resilience working to restore the system's balance. This distinction between static stability and resilience is crucial. While static stability is easily observable and measured by the variation in a system's state over time, resilience can be harder to perceive until its limits are exceeded and the system's structure is damaged. As a result, resilience is often sacrificed due to short-term obsessions with stability, productivity, or other more easily recognizable system properties. From now on, you will notice that the contextual games we propose test the resilience of the system and the player's ability to adapt and recover, essential skills for high performance. For example, a player who only trains in conditions of little or no wind will not have developed the resilience needed to adapt to hard windy conditions, nor will they be able to restore their usual swing or, in many cases, their confidence when playing into these new conditions. Playing in high winds requires recalculating distances differently, visualizing trajectories in new ways, performing more complex calculations, and engaging in out of the ordinary reasoning. All of these skills involve executive functions and cognitive abilities, which, if not well developed, will limit the player's ability to adapt to the playing environment. Another clear example of a resilience mechanism when considering a game system is the short game. A very good short game provides the resilience needed for when long is not good enough. Simply put, the short game compensates for missed fairways and greens, which, it is worth noting, tends to be the norm rather than the exception. Regarding the previous example, the lack of sun and good weather conditions in cold and rainy countries often leads players to spend more time building a supposedly tee-to-green system through repetitive practice on driving ranges or indoor facilities. This type of training tends to work well in low-difficulty conditions, such as low wind and receptive greens. In contrast, in warmer regions, it is more common to allocate more time to short game practice. This results in players who may be slightly less consistent from tee to green but possess much more creative and resilient playing systems. Consequently, as previously mentioned, it is crucial to understand the player's background, as well as their training dynamics and opportunities, to grasp their strengths and weaknesses. This allows for the design of training programs tailored to their specific needs. In conclusion, when we talk about learning in sports, we are referring to training. And when we talk about training within the framework of dynamic systems theory, we are referring to the individualization of training. To individualize training, it is crucial to understand the player being coached. We must identify their limitations and strengths, both physical and cognitive, in order to overcome the former and enhance the latter. In this approach to training or learning, the athlete will not always have a preconceived idea of the solutions they need to implement. This will encourage them to pay closer attention to how their system organizes itself. Instead of providing ready-made solutions, it is more effective to set challenges. The value of a good coach lies in guiding the player through the process of finding their own solutions. This approach encourages the player to make use of their self-organization capability. The coach can also learn from the athlete and the strategies they discover, making it easier to determine the most effective instructions or learning methods for that particular student. Therefore, during training, the focus should not be exclusively on repeating an ideal movement as the primary and sole perfect solution for improving performance. Instead, the athlete should be exposed to a wide variety of situations that allow them to create changes both physically and cognitively, modify the internal dynamics of their system, and acquire new experiences that lead them to discover solutions for the challenges they will face in competition. With this in mind, we will move on to the second part of the syllabus, which will address the composition, development, and functioning of the system's governance, our brain. In this section, we will also introduce some general concepts about executive functions and cognitive abilities. For more information about our Level 1 certification, please visit www.cognitivegrowth.pro. Let's move forward.